Nika Method, and today we are going to present you a data package for the analysis of dark field microscopy, or as we all know it, Darfix.
So before we start, if you had any issues on Darfix install, don't worry. We will dedicate some minutes to it during and after the break. If you have questions during the presentation, you can write them on the chat, and we will make several breaks during and after the presentation for questions and answers. If you want to know what's gonna come after during this tutorial, first I will introduce you to the dark field microscopy technique. It's going to be a very brief introduction, so for those that have never been in the microscope, probably we can have a longer discussion later. And then there's the introduction to Darfix that Julia will present you, where you will know the program. She will introduce you to the graphical user interface, and she'll tell you about all the future upgrades that we have already planned, where to find help when you need it, and then we will pass to the demo in which you can play a bit with some datasets that we have prepared. And I think that's all for the outline, so we can really get started. So dark field microscopy is a full field imaging technique that's particularly useful when you want to see embedded features inside your materials, such as grains, defects, domains. It's a non-destructive technique, meaning you bring us your sample and then you retrieve it whole, as long as it's thin enough for the beam to pass through, of course. And then you can visualize the 3D structure of your material, and you have contrast on strain and orientation, so you get an idea of the texture and the deformation of your lens. It goes without saying, but it's for crystalline materials. So if you want to know a bit about the microscope, a very simplified scheme is the one that you can see on the screen. So you would have an incident beam that will hit the specimen, and then you choose a singular reflection and you capture it in a detector that's 5 meters from it. And on the way, there's an objective lens. So you get a magnified image of your sample with contrast to this single reflection. If you do it this way, you get a projection of your sample. If we add a condenser lens in the middle, then we have a line beam that's very narrow and it goes through. And what you get is a slice of your sample, a slice through your sample. The resolution is of 150 nanometers approximately. And when you stack your layers together, you can reconstruct a 3D volume of the scan area. The sorts of experiments we can perform, the sort of scans we can normally do, the most famous ones, at least, are the rocking curves. So you scan your sample as a function of rocking angle, and you get the diffraction topograph. A mosaicity map where you scan through rocking and rolling angles, so you get the variations in the sample texture, and a strain map, where you use the rocking and the scattering angles, so mu and theta, and you see the variations of the d-spacing of the selected reflection. And now Julia will introduce you to the program.
Thanks, Raquel. So now I will start by telling you what Darfix is and how to use it, which is the main purpose of this tutorial. First of all, okay, so Darfix is a Python package for the analysis of dark field microscopy data. In particular, these data are images, and they are loaded either from EDF files, which is the current format in 96, or from HDF5 file format. This last format is currently being more and more used at the ESRF since the new beamline control system, GLIS, uses it, and it will be the main format in the future years. That's why we are implementing it, although it's yet not fully operational, because it only works in Darfix for one motor scans. Darfix is available as a standalone application, so you can import it in your scripts, or if you use Jupyter Notebook, you can also use it from there. And it's also available as a graphical user interface. The GUI is run using a program called Orange that allows you to create different workflows and link the different operations we have in Darfix. The different nodes in the workflows use widgets run and programmed with Qt and Silex. Silex is a library also from the ESRF. This tutorial will mainly show the graphical user interface part, but if you have any questions about the application itself, of course you can ask. So here you can see an example of a workflow in Orange. You have several nodes linked together through an object called dataset. This object contains all the needed information for the analysis. Darfix can be divided in 3 different parts. First of all, we have the data selection part, where you can load your images. These images can either be loaded into memory or be loaded from disk, image to image along the analysis. This second option is very useful if you don't have a lot of memory RAM because you are running Darfix in your own computer and don't have a cluster to run. And this way you won't crash due to memory error. Here in the data selection, you can also choose any dark files if you have some. The second part is the pre-processing, where you can apply operations like region of interest, removing of noise, or shift correction. And finally, the most interesting part would be the specific analysis for dark field microscopy. So since the data selection is pretty straightforward, we will show it just at the demonstration later, and I will go directly to the pre-processing part. First of all, I will show you how the dimension definition widget works. So this widget looks like this. As you can see, you have several buttons on the bottom. If you want to, basically the dimension definition allows you to choose any motors that move through the scan. If you have just one like here, or you have many, you can add them manually using the add button. And you can also choose the option to let Darfix automatically find these motors by clicking at the Find Dimensions button on here. It's important to know that in ID6 we have 2 different types of scan. We have the step scan and zap scans. For step scans, the detection of the motors is done automatically, usually. But with zap scans, the parameters can sometimes be wrong. That's why you should use the metadata widget that allows you to compare the parameters from the different motors and compare them to the original metadata in your scan. Also, if you have several motors moving at the same time, Darfix will show you all those motors, and you can choose which one you want to keep. So for each one of your motors, you will have a row like this that will show you the motor name. Then you will have the size, which means the number of steps, and the range. On the range, you have first the motor initial position, then the motor final position, and then the step size. Darfix will use the range to try to fit the different motors on your scan shape. If the step size is 0 or empty, it will use the number of steps instead of the step size to try to fit. After you've compared your parameters to the metadata if needed, and you think that your information is correct, you can try to fit, and you will have this nice pop-up that tells you if everything succeeded. After detecting the dimensions and finding the different moving motors, you can remove some noise if you have any. In Darfix, we have implemented 3 different techniques. First of all, we have the background subtraction. which allows you to compute a background from your stack of images, either using the mean or the median. I always recommend to use the median since it's more robust. If you have any dark files, you can also find the background using the dark files instead of the whole stack. Also, if your data is on disk and it's not all loaded into memory, you can either select chunks for computing the median, or using as a group of the stack. And that's because the median has to be computed with all the stack into memory. If that's not the case, by selecting chunks, you will compute the median by chunks of the images, or computing the median using as a group of the stack, which is the fastest way to do it, actually, because selecting chunks can take quite a long time. Then we have the hot pixel removal that basically finds small blobs of high intensity pixels in the images and removes it. These blobs can either be of kernel 3 or 5, depending on the size of those. So you can use a kernel of 3 and kernel of 5 if the blobs are big or small. And then we have the threshold removal, where, as the name suggests, you just remove the different pixels are lower than a certain threshold. After that, we have the shift detection and correction. So in Darfix, the shift is assumed to be linear. It is assumed to be linear along all the stack of images. This means that at a certain position in the stack, the shift applied to that image will be the sum of all your previous shifts, because the idea is to try to move all your images so that the brain is at the same position as the first image in the stack. You have the option to filter by dimension. This means that the shift is not applied at all the stack. The same shift is not applied at all the stack, but you find a different linear shift for all of the values of the fig of one of the dimensions you have in the stack. This is, of course, for datasets that have 2 motors or more. This means that, for example, if you look at here, where the circles are your images, and this is the shape of your dataset, if you fix, for example, if you filter by the dimension 2, then you will have a different linear shift for the first row, a second linear shift for the second row, etc. The same would happen if you filter by dimension 1, but with the columns. Here you can see an example of why it's important to do a preprocessing before any analysis. At this first image, you can see a sum of all your stack before any preprocessing is applied. At the second image, you see the same sum, but after having applied background subtraction and threshold removal. And finally, you see the ZZoom with hot pixel removal and shift correction. And as you can see, the image is much more sharp and neated. Okay, so after having talked to you a bit about how the preprocessing and also what Raquel has explained, if you have any questions about this part, we can answer them now, and then we can continue with the second part of the presentation.
We can start with Emilio's question that was written in chat.
Okay.
And actually is the note about the dimension definition widget appearing in ESRF widgets instead of in the normal widgets box, in the Darfix widget box. This was it's a bug that is going to be fixed.
Yeah.
And it was just in the latest release, the dimension definition decided to migrate to a second folder.
Yes,
but,
it's in the there's not a a new release that I did on Friday that later we will update, and this particular widget will be removed from that folder.
So we'll be teaching you how to update Darfix. Congratulations. So
one question maybe from my side. I noticed when I used the shift correction that there is a star-like distortion in the scan afterwards, and I have to apply a second noise removal with a pretty low threshold removal so that this gets removed. Is this some error on my part, or can this happen?
it's not a problem on your part. It's like that. When you apply the shift correction, you actually have all these pixels in this place, which induces some noise around the shape of your material. Since it's induced, the moment you apply a threshold of 1, it's gone, and you're not losing any further data.
Okay, perfect, thank you. And one second notice on the dimension widget. In my data for the differ y dimension, it always, if I do find dimension, it takes the wrong step size. I correct it now manually, it's no problem, but I just noticed that for all other dimensions, it's correct, but for this one, it takes a wrong one by a factor of 10 or something. That's just what I noticed.
There's a big chance that most of your scans are sub-scans. Is this correct?
Subscans means?
That when we integrate along the acquisition during the data sets. Do you remember how well, actually it's written in the metadata. If you use the metadata widget, you can see if it was an A scan or a sub-scan. If it's a sub-scan, they always, the widget can always get it wrong because we get a gazillion different stop points since the motor so the acquisition is integrating in between every 2 steps. The steps are normally not counted in exactly on the same points. The number of decimals vary slightly. If it happens on the step scans, normally it only happens when you have very, very small steps. So you are kind of flirting with the limit of the resolution of the thing. Actually, it's maybe the number of decimals that Silex accepted.
Yes.
And so then you have to impose the step size. But it's
yes, if it's the step scan, it should be corrected in a future release because we just saw it last week. Workout told me that some of the step scans were wrongly taking the resolution of the step size. But for that scan, it's happening normally. Yeah.
Yeah, it's a subscan. I remembered now. Thank you. Yes, yes.
Any other question? We can see the chat.
Yes.
Sorry, just one more question. Just what I noticed is if I use the data from disk option because I don't have enough memory, I sometimes in the end part get an error message. I think I sent it to you once with can't compute the 0 array something. Do you know if this happens to some error on my side, or I just use it now on my RAM? It works, but I just noticed.
I have only ever seen that error pop up when you're overwriting, for example, one shift. Like you applied one and then you want to change it and you want to apply another one. I am not familiar with it, so I think we can, if you send it again, we'll tell you at the end of the presentation where to send us all the errors that pop up and so on, so we can check them. And then, we'll look into it again because I really cannot remember what that was about. Aside of this, sometimes the data overlaps when you have treated one dataset twice. How long have you had the version you have now?
Sorry, what was the question? How long do I?
How long since you have last updated Darfix?
I updated Darfix last week on Tuesday. So somewhere in the last 2 weeks, I updated it.
Okay, then it's not from 3 months ago. That's good to know already. Good.
We can take a maybe if you have time later after the demonstration or so.
No hurry.
Not okay, you can send us the error and we will take a look at it.
Thank you.
Okay, so if there are no more questions, we will continue.
Any other questions? Because I don't have more in the chat, so
no. Okay, so after having showed you how the preprocessing works, I will show you the different data dark field microscopy analysis widgets. First, I will start with the ZZoom, which we saw a bit at the previous slide. Then we'll continue with the point plot, the rocking curves, and the Lancer separation techniques. So the ZZoom basically it's a sum over all the stack of your images. This widget is very useful if as a fast way to verify that your preprocessing is correctly done. How can you do it? So basically you can compare the ZZoom before any preprocessing has been applied. Then, for example, you can use it after noise removal, since you can see if all the hot pixels have been correctly deleted, if there is some noise in the background, of any threshold should be removed. Then you can also use it after the shift correction to see if the grain is correctly shifted, if it appears still some shift, etc. And you can see that after the shift has been corrected, the grain is much more sharp. Then we have the rainbow widget. So the rainbow widget shows 4 different maps if your dataset is has a one moving motor. First of all, we have the center of mass map, which basically is the first order moment, and it corresponds to the peak position. So the center of mass, it looks at the intensity as a function of the motor position and uses the intensity value of your images as statistical weight. Here you have an example of what the center of mass looks like, and the color bar that uses the different motor values of that particular motor. Then we have the full width half maximum map, which corresponds to the variance with this formula here. So basically, it's proportional to the variance. Then the skewness or third order moment, and the kurtosis or fourth order moment. If you have more than one dimension, you will have several maps for each of those four operations we showed at the previous slide. So basically, if you have two moving motors, you will have a different center of mass map for each of those. Also, for 2 moving motor scans, we have mosaicity maps and orientation distribution maps. The mosaicity map is a color image that if represented as HSV, it has the color map, the center of mass of the first motor as hue, and the center of mass of the second motor as saturation. To be able to understand the mosaicity map, we have the orientation distribution map, which looks like this. Basically, it has the motor positions in the axis, and it allows you to look at the colors in the map and compare it with the mosaicity map and see which color corresponds to the motor position values. You can also take a look at the contour plot, which is the contour of the orientation distribution, and see where there is more intensity in your scan. Here we have an example of also the full width half maximum map, skewness, and the kurtosis. Then we have the rocking curve widget. So the rocking curve widget performs the fit at each pixel of the data. This fit follows a single Gaussian model, and after fitting, we show 4 different maps: the integrated intensity map, the peak position, the full width half maximum, and the residuals. These maps are computed using all the stack of the fitted images. Here you can see how does the rocking curve widget look like. Basically, we have on the top left a stack of all our images. Moving through this stack, we can choose at any point. We can select a pixel on the image, and the corresponding rocking curve for that pixel will appear as the blue curve on the right plot. The red curve in this plot is the actual fitted blocking curve. The classic blocking curve is a scan using only one motor. So if you have more than one motor scans, you have to filter by dimension by clicking at the checkbox in here. When you filter by dimension, you can choose any one of your motors, and you will see for each of the values of your motors, you will see their corresponding images. The fit is done consecutively for all the values of your motors. So the export images use all of this tag and not only the values selected at the beginning. If you want to fit the data also for the second motor, you can change it and fit again, and the images, the maps will be different. So that you can export it and have it saved on your device. And then we have the blind source separation widget. So the blind source separation basically finds the components that best represent the data set. These components are actual images. The blind source separation has many methods that can be implemented. Basically, what blind source separation does is, first, we create a matrix X that has all our images in the rows, the flattened images in the rows. And the idea of a blind source separation is to try to decompose this matrix into two different matrices, H and W, where H will have our components in the rows, or flattened components in the rows, and W is a mixing matrix that is also usable for a part of the analysis. So we've created a test data set to show you how those blind source, how every one of the implemented methods in Darfix work, and why should they be used or why not. Basically, these are the original images, and we created a stack of images like this one to test every one of these methods and try to find the original components. So first of all, we have the PCA method, or principal component analysis. PCA recovers the orthogonal vectors, and these are our principal components. The problem with PCA is that it doesn't take into account the fact that the images are positive, so that the output in the end is not very good. As you can see here, this is an example of the BSS widget applied to the previous stack of images using PCA. And as we can see, the output components are actually not very good, because what we want is to have different figures at our images. Then we have the Nika method, or non-negative independent component analysis. Basically, it constrains our components to be statistically independent, and it adds the non-negativity that we previously have with PCA. The only problem with this method is that the mixing matrix, so the second matrix of the decomposition, doesn't have to be positive. Although this method works better than PCA, it's still not usable for our kind of data. And then we have NMF, or non-negative matrix factorization, which only constraint is the fact that the two matrices has to be positive. This method it works actually pretty good, and it has the best ratio results computation time. So basically, if you don't have a lot of time to compute the blind source separation, you can use this method, and it's actually very fast. The only problem with NMF is that the output is not unique, because it has an infinite numbers of solutions. And the final method is the combination of Nika and NMF. Basically, we use NMF, but using as initialization the output of Nika. So basically, we use the Nika components to start the method and NMF and have a unique solution. This method provides both negativity and solves the initialization problem. And as we can see here, it's the method that actually gives best results. So to sum up, before summing up, I want to tell you that you may think, why do we have the PCA implemented if it actually doesn't work well with our components? So PCA is very good for dimensionality reduction. And this helps us because it helps us know how many components can we use for our data sets. How can we do that? Basically, we have a PCA widget that looks like this and shows a curve to see how many components are best represent the data set. So basically, as long as this curve here goes down, the components has less representation along the data set. In this case, we could say, okay, maybe we have 5 components that represent the data set. We can also look at the mosaicity map and the orientation distribution map and try to see how many components do we see and compare them with the PCA curve. And now, yes, to sum up, we have 4 methods: PCA, which show the principal components that best represent the data; Nika, that adds the non-negativity constraint in the components; NMF, that adds the non-negativity in the mixing matrix; and finally, Nika NMF, that solves the integration problem from NMF. Here is an example from a real data set where we used Nika NMF, and we chose 3 components. So actually, it's the same curve in here. We chose these 3 first components. And the output is this one. So we would say that maybe the first component would be, for example, the blue part in our mosaicity map. The second component could be maybe the yellow, and the third one could be the green part. As you can see, it depends a lot on how we see things. So it's important that every one of the users that use line source separation looks at the output and decides how many components are better, etc. And maybe also which method works better for your kind of data set. After telling you a bit of our most used widgets, I will tell you now of some of the widgets that can make easier for you to do the analysis. First of all, we have the transformation widget, which basically applies a chosen transformation to the data axis. It can either be unification or for RSM scans. Then we have a data copy, which is a widget to be used if data is on disk. It's to be used if you want at a certain point of the workflow to save the treated data, because otherwise it will be overwritten in future steps of the workflow. Then we have the partition data, which allows you to separate the data into the images that have low intensity and the other part of the images. This way it may make the analysis faster. And then you have the flash widget, which is in cases where your data is on memory. It allows you to free memory in cases that you see that you are running out of memory RAM, but you still will have to do more analysis. You can use the flash method, and all the previous memory in the previous widgets will be deleted. And then finally, we have the link components. This widget is to be used if you have several data sets that are, for example, similar, and you want to compare the different components found with one method and the other. It tries to feature match those components and see how they link together. And finally, we have, since not a long time, have implemented the batch processing, which allows you to do, for now, via the terminal. It allows you to execute the same workflow you've previously created with Orange, but automatically. So basically, if you have saved the workflow and saved certain parameters, it will run with any data set you want it to run without the need to start in the GUI. This part is still in progress. We have some bugs that need to be fixed, but it can already be used. And then I'll go to the future updates, the things that we are working on. Basically, we have we are first of all working group with 2D data sets because we want to improve with that. We have an option, we are working on an option to project the moving images from one motor to the other. This way we will only have a peak for every one of our pixels, and the fitting will be done better. And also we have the option to use a fit function that depends on both motor positions. Then we are also adding the option to apply some binning on our images so that the analysis is done faster, and to add a workflow title along the different plots so that you can link together. If you want, you can save and then look at the images and know which workflow do they come from, without having to know it from before. We are also working at the 3D reconstruction. First of all, we are working in using 3D reconstruction to show the different mosaicity maps from different data sets. So for example, if you have a scan with different layers, we are trying to reconstruct the different mosaicity maps to have it all together from all of the different layers of your data set, of your scan. And we are also working on adding a 3D map for the data set that have more than 2 motors. So if you have a data set with 3 motors, which in 96 we actually have some, the idea is to show mosaicity map like this photo in here, so that it has the 2 motors and the third one as the z-axis. And finally, we have the batch processing, and I told you it's still a work in progress. We are working also to apply it consecutively to all the data sets in a folder, so you don't have to go one by one and doing it. And also we are creating a widget that allows you to do the batch processing using the GUI if you don't like terminals and so. So finally, just to finalize, we have a Darfix mailing list. If you have any questions, issues, and also we will send you, if you are subscribed, we will send you the updates that we do. Then we also have a Gitlab repository. You want to take a look at the code. And also in here, you can also add issues if you have found any error. You can add it in here in the repository. We can also have, you can also find the documentation of the latest release available here. It's the documentation of the code. So if you want a user's guide, it will be available soon. But for now, we only have this documentation here. And finally, we are working in an article that to be submitted soon, we hope. And that's it. So if you have any questions about this last part, you want to comment on something, now is the time. Okay. See,
You can raise your hand if
yes, raise your hand or unmute you.
write the question in the chat.
Yes, everything is okay. If not, after the question, we'll do a break. We'll continue later with the demonstration. Okay.
So apparently, Julia, you have been super clear.
Yeah, it seems like we'll do the break now. If you also think about any questions during the break,
I could say first, if there's
yes.
a question.
There's a question now?
Oh, yeah, it was just very clear. It was a very clear presentation.
Okay.
There's a question we have for you. I already asked at the beginning of the tutorial, but not everyone was there. Is there anyone that has had a problem with the installation of Darfix? Everyone managed to install it all right. Great. And then if anybody has tested the access through the Guacamole application, so it's a remote ESRF.var, and then you try to enter with your identifiers from your user's account, If that is successful, then we can all follow the tutorial through there and you can test different data sets we have prepared. Else you can follow it from the installation you have done in your computer. First thing we'll do after the break is to teach you how to upgrade the last version of Darfix you have.
Exactly. If some of you couldn't answer guacamole, we will try to contact Gabriel and see what we can do. Or in any case, we send you the test data set. So if you have successfully installed Darfix in your computer, you should be able to run the demonstration good.
So we meet again at 10 and 10 minutes. You have a 20-minute break now. And if anybody wants to ask us questions during the break,
Yeah.
you can write them in the chat because we might leave the room, but we'll collect them right at the end of the break. Okay?
If everyone has succeeded in opening remote, in opening guacamole, we will start with the demonstration. I think no one had a problem because no one told us anything. So we can go after you have allocated. Maybe I will share my screen with what I'm doing. So stop sharing here. Okay, so as I pasted to you on the chat, here I will now allocate the resources we need. Once you have allocated it, you should have something like this, where it tells you that you are in this node of the cluster. And after that, you can try to open the Darfix environment. Okay.
And you all see the shared screen.
Yeah, because in principle, you should be able to see the terminal, but I don't know if it has been done.
I can see the share screen, so I confirm that
Okay.
they should be able to
Good.
see.
So I will paste in the chat how can you activate the Darfix environment. Basically, the thing you see here in the terminal. And after activating it, we have Darfix in here, and you should be able to run Orange. And if no one says anything, everything is working fine. So first of all, we will start by creating the data selection widget, which looks like this. And we will upload the first data set. Should we start with the rocking or with the strain?
We can start with the strain. I think it's a
Okay.
more general case than rocking. The rocking is very easy, very fast, and they can do it themselves. The strain might be a bit more tricky.
Okay, so we will start with the strain. Basically, you have to go in computer first. When you open the upload file, you go in the computer, and then you try to find here 1014 days. In here, you should have the Darfix tutorial user meeting folder, and here the string folder. Once the files have charged, you can select the first file of the stack. This I will tell you, it's important that if you have several file numbers that don't start with the same number, so for example, if you had here 0000, but at the middle of your scan, you didn't have the continuation of the numbers like in B, that it ends at 960. If you had, for example, 0100, but in the same data set, it's better if you load all your images using the add button in here. With this, you can load all the images. And you can see them.
You have a zip at the end of the folder, and you
Oh, okay. Yeah, now it's okay.
Now you have seen how to use remove button as well.
Exactly. Also, we will test some dark data. So if we go to the dark data tab, we'll click upload and go to the previous directory here where it says background effect and select the first file. And finally, we go to the treated data folder. This will allow you to choose a folder where you have wide permission and save all the different data sets, all the different treated data we will be doing along the workflow. For this, you could go here. I have my name, but you probably have yours in here, and you can create a new folder by clicking at this button, like I did. I create a folder called Darfix tutorial. You go in there and you just select choose. And after that, we won't use the use data from this because we are in the cluster and we have enough memory for this data set. So we just click OK and it should work fine for everyone. Just check no one said anything. So I guess it's all good. Now we will leave this downloading and we can go back to the workflow while it loads. And from here, you can select it and create a new widget. We will start with the metadata widget. And we will also create a new branch for the dimension definition, like this. So that after the data has finished loading, these two branches will change a bit and they will open. So you can, well, in fact, the dimension definition will open and the metadata, you have to open it by yourself if you want it. Okay. Yeah, it has the same error. Okay, this is an error some of my colleagues told me they had in the cluster, didn't know why. So if this error appears to you too, then we'll go back to the treated data folder and we will create a folder in the temp 14 folder. In 10-14 days. So basically, we go to the 10-14 days as before, and we create a new folder called, you can call it your name. In my case, it exists already, so we'll create a second one. And from here, I hope we are able to run the data set. So I think everyone had the same problem. Okay, we managed to do it with the second way. If some of you managed to do it, I'm going to say okay in the chat to have some feedback for us.
Yes, we would love to have some feedback.
Once it has finished loading, we can open the metadata folder. Here we can see the different metadata. For every row is a different image. You can go at the end.
So all of those are all the motors that you have that are coming from the inline, and you probably will recognize some of them as the diffry, the chi, the phi, all your FXZs or all your objective motors. Those are the ones that are going to move. One good thing to do normally is to scroll down the whole metadata folder in instead of in position or in the default parameters to find which type of scan you have. If it's an A scan, it's going to be at the beginning. If it's a ZAP scan, it's going to be at the end because they are ordered somewhat alphabetically. And you scroll down, and you see a couple of things. First, you see that it's an A scan and not a Z scan. So you expect your dimension definition widget to work fine. Second, you see that you don't have any extra files, like when you accidentally took a CT without saving off. Then you also see which were the ranges that were written, like from which position, initial position to which last position you went, how many steps you took, and how many seconds you waited for acquisition time. This is very useful when you have to give an input manually to the dimension definition, but as we just said, this is an A scan, so probably it's going to do it fine on its own.
Okay. Also, here at some of the scans, you have here the value -1 or of the first of the quick motor. Is it that right?
Maybe yes.
But it's not in all of them, and sometimes it's the size, so it's the number of steps or the number of steps -1. Depends on the scan.
That's one. I think it takes either 30 steps. In this case, it's going to be 31. And
It's
this
31.
exactly. Is going to
That's
be
one,
30.
yeah. Yeah, exactly. That one.
Yeah.
So no one said anything?
No, it's okay. We can do it.
Okay. After this, we can continue to, you can go to the dimension definition widget. This one. We have the metadata type as positioner. This is important because we have also different kinds of metadata, but we usually want to filter and find the different motors.
It is useful from time to time to use the counters. If you have, for example, a power source and you are doing an in situ sort of experiment, or if you were counting time to know at which particular moment an image was taken, but else, in general, it's the positioner that you're interested in.
Exactly. And after that, you just click define dimensions. And as I commented in the presentation, here we see 4 different motors, but actually FFZ, OVZ, and OV pitch are moving at the same time. So in this case, we are only interested in saying
OV pitch, because it's the two-to-tango.
So here on the right, we can remove the 2 motors that are unlimited. And then we can open it a bit and check the range, and check that the range makes sense. As well, we can compare it with the metadata. So like this. Okay, so as you can see, the final start and the final, the initial position and the final are the same for the different one, which is the one that is the information we have in the metadata. We actually don't have the information in the second motor, right? In the metadata?
Yes, but you have to go to the column in the positioners and scroll down the second motor and count your.
Exactly. Yes, we have it in.
Yeah.
Exactly. We could search here for all bit pitch, which is in here, and check.
And so you will see that every 30 images you change the value, and you can look at the first value from the first column and the last value from the last column. So you have your initial and final values for each. And
okay. But normally, as this is the step scan, it should work fine, and you can.
In general, the second motor, since it's the slow motor, always works fine because it's taking steps.
Yeah,
The first one is the one that's integrated, and then you might have problems.
So after that, you can try to fit, and if everything is okay, you can continue. So after finding the dimensions, do you want me to try the transformation widget or?
Yes.
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 We will show you a widget that we will present in the presentation, which is, well, I presented it, but we can see how it works. So basically the transformation widget, you can choose a different magnification value. Is it the pixel size that changes?
So it's adapted to the 2 cameras that we have in the far field. It's either 2x magnification or 10x magnification, and yes, it corresponds to the magnification of the camera with respect to the magnification that we had already because of the distance. So you can also add a manual magnification. This might be useful if you have older data or data from another line that has X-ray imaging. And then there's a topography button that you will want to click if you're doing layers. We don't want to click it today because this is a projection. So we don't need to transform anything. We call it topography because, but it's just a reference to if it's a layer or if it's a projection scan. And then yeah, you can center or not center your axis. If you don't center your axis, what happens?
If you don't center it, the zero value starts at the left side of your plots, and if you center it, the zero is at the center, basically. So depending on what kind of maps of plots do you want to have, you can center that.
If you don't want to see negative microns,
Exactly, that's it. We center it now. We don't.
yeah,
Okay. After this it's important that the transformation is done before the region of interest widget, although it may work if you apply it later, but I prefer that you apply it before the region of interest widget, because then if you change the size of the images, it might not work properly. The values might be wrong. So now we can add the region of interest. Here you can move through your stack like this. You can see that the grain is moving, and you can choose a region of interest that contains the grain, so it will make the analysis much faster. With this type of grain, it's important to leave a bit of
space below and up.
space for the shift correction, especially because in this case the grain is moving downwards, so it starts in here more or less, and it ends in here. So it's important also to leave enough space so that the grain appears correctly. We can. This is the select widget, and you have several tools in the bar here on the top. You can choose to change the color map. For example, if you choose the logarithmic, you will see it more clearly to apply the void. And you can see that how the grain shifts along the dataset. You can also change the color map if you prefer. Another one will be and also auto scale if you like. Remove the auto scale. Once you think your region of interest is correct, you can click OK, and we will go to the next widget. Questions? Okay. So now we can apply we can remove any noise that appears. So we will use the dark files. Here we can choose dark data and use the median, since we prefer it to the mean, and try to compute it by clicking the compute button. After that, we will see, okay, it's finished, and we see that the grain is actually much more needed, and you can see it much better than before. After that, I think, do you prefer applying first the threshold than the hot pixel?
So there's different schools. If you see that you have hot pixels around your grain, you can start by applying the hot pixel removal. If, like, for example, in that image will have been a situation in which you decided that you rather apply threshold because the pixels are everywhere. But you can do either of both. You can either apply first the hot pixel removal, then the threshold, and then do a second hot pixel removal, because some of them will pop up back when you do the threshold removal. Or you can directly start with the threshold removal and then apply your hot pixel removal.
Yeah, actually, in these images, as there is not a lot of intensity and the color map values are specific for every one of the images in the stack, you see, okay, there's a lot of noise here, but it's actually probably the same noise as the other image, just that here you have much more intensity in the pixel of the grain. But here there's not a lot of intensity. So now we should apply
I would say you can do one hot
Threshold?
pixel,
one hot pixel.
and then you do threshold, and then you redo hot pixel.
Okay.
This dataset had a lot of hot pixels. It's the dataset that you saw before in the presentation. I don't know if we can move.
Actually, the one in the presentation was the mosaicity.
No, it was, the dataset with the corrections was the strain. The
Okay.
mosaicity map was the mosaicity of the grain.
Okay. If we put the logarithmic scale, we see much more if there is noise or if there isn't. So you can see there's a lot of noise here that we can remove. Maybe we can move through the different pixels and see more or less which value do they have. So it goes from 0 to 6, maybe the one highest that I saw.
I think like what I use as a cheat sheet is the palette of colors. So you can move there, you can scroll up in your bar, you remove the auto scale, and then you see when your pixels start disappearing. And you also pay attention to the grain to see that the information from the grain is not being lost.
Exactly. So here we could put 6.
I think, yeah, six should be a good compromise.
Here and set compute. If you go here and set the auto scale again. Scale, we see that now, even with the auto scale, the output is much more better than before. There are still some hot pixels, so maybe we can try to remove those by applying them for a moment. Okay, it looks much more better now. Do you want to show something like the presentation?
No, it was only for the grain that actually, even after applying all this, we will still have some clusters of information around that might or might not be from other grains and from real things, or they may only be pixels. So that we will only see once we have finished all the data treatment, because even if we do the ZZoom, in this case, they won't show. They are so low in intensity that they won't show.
Yeah, okay. They actually show in the mosaicity map.
Yes.
The red block. Yeah, we'll see that later. Okay, so after this, we can go to correct the shift. Here. Okay. So this is the shift correction widget. Here is the option to filter by dimension, where in this case, okay, so if you filter by dimension DFY, the images that appear here are the images that correspond to that value of DFY. If you change the value, the images change. The idea when you find the shift, when you filter by dimension, is that it finds a different shift for all of your values in here. It finds them automatically, so you don't have to go one by one and find them. It finds them all at once, and when you change, you would see how this changes. Actually, we can try to find them. It may take a while, but we can show it. And here in the terminal, you see how all of the different file shifts are being found. Every one of these, you make it bigger, you will see it better. It will do this 31 times because our DFY dimension has 31 different values. Once it finishes, you will see here different shift for when you move through the value of the motor. And here you can also move and see how the shift moves through all of your values.
If you've been paying attention to how the grain moves, you already know that this is a very good example of a linear shift. This mostly happens when your sample, by any chance, was out of the center of rotation. So there's this progressive drift of the grain in space. And in that case, the best is to directly go for the linear shift correction. It will also take time. The finding the shift always takes time, but it should give you a very good result straight away.
Yeah. And actually, in this case, the shift is linear along the dataset and not along the dimensions. I'm computing it to show you how it works exactly. So here now it has finished. we see that for this value, we have this horizontal and this vertical shift. And if we move another value, this value changes. You can also manually change any of these values, and when you click to correct, it will use the new values you have entered. If you click here to apply only the selected value, when you correct, it will only modify this value of the motor and not all of them. But in this case, we won't filter by dimension. We will try to find the shift linearly all along the stack. Which you see here, while it computes, and as you can see, it's a bit slower because it's using all the stack now and not going dimension by and value of the dimension by value. You can also, when filtering, you can also change to the second motor, and it will be the same as it was with the first one.
Question?
I don't know if my chat knows. I think it's my preferred chat. Okay, I guess some of you, or maybe all of you, weren't able to connect to Learn because Gabriel just told us that they encountered problems with their file server and the automatic creation of their accounts failed. Now the problem is fixed, so could you please try to log in again to the Guacamole, and if it works, you will have this same data set able to you to test, because the data sets that we send don't have the same dimension as this one. So it's a smaller data set. The string, the rocking is actually the same, but the string is smaller, and the output won't be actually correct because some of the images are missing. I don't know if.
I mean, it's good enough to test the widgets, but you won't see the same result as we do, which might be confusion.
Exactly, and also you may not have the last version of Darfix.
Yeah, we were gonna teach them how to update.
Yes, I will put at the for if you have Orange open, I guess now you don't want to update it. So maybe we finish because this should be the same.
Yeah.
We will finish with the demo now, and then we finish with this with the strain. We will show you how to we will close Orange and show you how to update graphics and then open it again. Okay, there's chat. I can connect now. Okay, good. Good. If you can connect now, do you want us to go back and maybe see again the different steps? We can maybe do it. I can open a new chat now just to show you the different steps you should follow. Basically, first of all, you have to enter the allocation command line to allocate the memory. It's this one.
They have the time to write it because we just have it there. But
Yeah. You have the same. Well,
yeah, you can copy it from the chats on the Zoom.
From the chat. But in case, we wait for 30 seconds, and then after this, you can open the graphics environment, which I will show you now. It's the second message I set in the chat. Now just before loop message. So after allocating, you can activate the environment like this. Okay, and if it's correctly activated, you can open the range. And if I go back to your orange, in case I will go back here. Here you have your widgets. When you have opened the range, you should have Darfix on the left. Maybe you have other widget, but in principle, I don't know in your form,
In my SARM is
Is it
normal, it's
different?
like this, it's only the ESRF widgets only appear in the downloaded version. for
Okay.
Windows.
Okay. So you can add the data selection widget and open it and add, upload a file here or write manually. The
Raw data,
raw data, which I will also enter because we didn't put it in the chat. I will enter it. So it's 10, 14 days. Darfix tutorial. Then. Great. This is, and here you can load all your data by clicking Control A and you add. You go to this tutorial.
yes. On that note, this adding the data is order sensitive, meaning if you invert the columns, you start adding your files from the last, you will flip your map
Exactly.
and your results will not be like reality.
Exactly. It's important that they go from first value to the last one. If you click here, if they are ordered, you click Control A.
Is that true for all of the positions, Tobias?
Right now, I tried it only for differ-y, but I tried it with personal data with different dimensions, and I noticed when it's toggled on that it's always 0, something in my software. I mean, if I don't toggle it on, it finds a normal shift, and it looks pretty good actually.
Yeah.
But that's just I noticed with.
It's maybe because maybe you don't have any shifting type.
Okay, but it was now at this data too, and there should have been a shift, shouldn't it? Right now I got result 2 when I got on filter dimension with this data set you have here. I downloaded it, so I have the reduced one. Of course, it's different, but the result was 0. And when I put the toggle off and just normally find shift, then it found something a slightly different value than yours.
Okay. The data set you downloaded is the one that we sent you.
Yes.
That it's a shortened version of the original data set. So it's probable that the values of diffraction don't only have two images.
Yeah.
If you look at the stack of images for each of your values, you should see it either you have 0 to 30 or 0 to 1. If you have 0 to 1, then you are looking for a shift on only 2 images, and it's normal that it doesn't found them. So I just to run it through OVPitch, and then you should have the correct dimensions. If you want to correct the data set, if you want to correct this data set, you can correct to learn. It's pretty easy, and you will have the same results as. Otherwise, you would have wrong results, especially for the orientation distribution map, which we will see later, because you don't have all the images needed. You don't have all the model positions.
Thank you.
Okay. So back here.
But what worries me is that he finds the same thing for his own data, and in his own data he should have more than 2 images. So there's 2 possibilities there. Either since they were subscans, there was a velocity problem, and then you only have the first and the last image for each scan at one motor position for diffraction, which is worrisome, or I don't know. So we can check it later if you want.
In any case, I will check it after he has updated to the latest version, because this version, I don't know how the filter, because we updated it, but I think it should work fine. I think your version should work fine, so we will check it out later.
Yes.
Yeah. So for those that have connected now to Guacamole, and they have currently opened the range, you should be able to also add the different dot files. I will put it also on the chat.
If anyone has had to restart and is a bit lost or has problems on previous widgets, we don't mind being asked flashback questions. It's okay.
Exactly. This is a tutorial, and of course, if you have just the
If we
when
were
the
here in a
one-
room, we would be with each of you. You would have each your data sets, and we would be checking that everything's okay.
yes, exactly.
So there's some.
But the comments does not work.
Oh,
Can you copy paste your how your salad? Did you copy paste it from what I entered, or
is it minus the X11?
you cannot copy and paste? Ah, yeah,
Yeah.
that's a problem. You can? No, you cannot. Yes. Just make sure, because maybe you left something. Maybe you left something in the command, because it should work. Look, could you allocate?
Okay. So it well.
The command salad itself does not work.
I'm gonna try it from mine.
Okay. Was anyone able to allocate? Because I'm writing to Gabriel to see if this could be a possibility.
Julia, is this the one Gabriela sent us?
What?
Is that the one Gabriela sent us?
I just added the
I think that was the
X11
one.
because she forgot the X11. Okay.
Yeah.
Is anyone else having problem with the salad, or could anyone else allocate? Please, it would be good for us to know, because it would tell that Gabriel that.
But there's the reservation Darfix part missing. So maybe they are trying to take a part of the interactive cluster.
Can you hear
And
me?
in that case, there's
Okay.
gonna be, no. The hello
okay,
command
yes.
doesn't work because we are all booking it, so it's probably full. I'll pass you a new command.
It's this
And
one.
in this one, there's an X11 missing somewhere. Where is it, Julia? Después de dónde?
I added it in the chat now. It's this one. Yep, this one. You could try this one. Yeah, because the one I added it's the previous one that it may not work. I will manually add it to the. So it's salloc X11 first reservation equals Darfix like this. Nodes 1 CPUs your task 5 time 0.3
Or 02?
or 0. Well, yes, we get to 0.2 because it's already
Unless you wanna stick with us for 3 hours.
for DJ and run PTI and bash.
So of course, the first 4 people that requested time got the allocation. But yeah, everyone should take it from reservation Darfix because there's more time allocated for this one.
Exactly.
More space. Time is the.
Yes, the one that I sent in the chat, but I forgot to change it in the terminal since I put the last one I entered. It's better to allocate with this. If you prefer, we can close the preview orange and we can directly start it from here. That Control C and Control D. Go back to this one. With that, you can open the environment, which is source SciSoft, Darfix, Miniconda, build, activate, Darfix. And then canvas.
So Emilio's telling us that there's a problem with this. But our workspace and your workspace in Guacamole. When you enter through Guacamole, which space did you choose? You had to go into Slurm. Maybe we should show that.
When you're the, yes.
Yeah, because there's the
So-
teleworking and there's the other part.
Exactly, let's check that.
So yeah, so when you enter in Guacamole, they are not seeing that part of the screen. Yes, yes they are.
Yes?
Yeah, so it's in computer cluster, and then you choose Slurm, and you choose one of the.
Exactly.
Computers
I
in
thought
Slurm.
they will have directly only
Yeah,
Slurm.
we thought that you would directly be entered into Slurm, but apparently,
Okay, wait. Good. Good then.
okay, so once you get to Slurm, you can do the SLO.
Yes. Sorry for that. Let's hope now it works good. Were you able to also activate the environment and open orange?
Excuse me, can you hear me?
Yes.
I don't see the Slurm in this remote ESRF. Now, was it allocated only for the attendant of the meeting? Because I'm here for the Peter Schittner, but I'm connected to ES remote through my own.
Yeah, so the
account.
question, so in order to access to this reservation, to
Yeah.
be given access to the Slurm partition and so on, you need to use the, I mean, I think it's only enabled for the people that were inscribed into
Okay.
into the
But
group.
listen, I have solved the issue because I copied from the temporary file, from the temporary director, the complete data set. So now I have it on my.
Okay, that's good. If you manage to install it and you have the complete data set, then you're all set to go.
I have, so don't worry. Okay, good.
Okay. I hope everyone else was able to open. Emilio, are you in orange now? Were you able to open it?
Hey, yeah, I made the same mistake. So I just connect onto Storm and then it seems to work.
Okay, good. If
So let's try from there. Yeah.
okay.
I didn't see the chat.
Yeah, so we give you a bit more time to
open orange.
open orange. And then if someone wants to volunteer and show us how to load a data set.
Exactly. This way, you can have some feedback from you and see, and you can also try it yourself for sure, and you can answer any problem or question. You can stop sharing and you can share your screen, and we see how you do it. You were able to correctly connect?
I was able to correctly connect an ipso facto the network in the ESRF.
Okay.
So since I'm not plugged in with an Ethernet cable, I'm out.
Okay, I guess everyone else were already open the range and has the same window as we do.
Yes.
Then we go back to the data selection widget and we load the first file in the temporary 14 days folder under Darfix tutorial stream, which you have this also in the chat. You can just select the first one because in this case it's good. Then we can go to the dark data tab and also add the dark file.
Yeah. And now when you go into your treated data, you're going to be very careful because you have already saved a treated folder with the same data set.
Don't worry, it gets subscribed. It exists. So if you have already done that, don't worry. You can reduce this. Just don't do again. Don't create again your folder. So if you already have it, you just find it.
Yes. I heard a voice for a second there, but then.
Yeah, it was, sorry. I don't have the treated data tab in my version.
Well, now that's worrisome.
Yeah. Okay.
Yeah, that might be problematic.
Do you are in Solar?
Sorry?
Are you in Guacamole in?
No, this is, I copied your data set, so, but I installed it on Friday, the latest version.
Friday was the last.
Yes,
right?
Friday afternoon.
So, yeah, so
Okay.
did you, first question, is it a Linux install or a Windows install?
Linux.
Maybe just redo the pip install Darfix.
If
Yeah.
you want to
Okay.
share your screen, we can do it
Yeah.
together.
If you want to share the screen, we can try to help you from here, see if
Okay.
we can manage to get that
Okay.
tab.
I'll stop sharing for now.
Okay,
So
yeah, good.
it is good because if anyone has the same problem, we can then also help them with how we do it with you. So
Okay, let me. Well, what do you see now?
Yeah, we see that you don't have the tab.
Yeah, okay. So shall I? Mhm.
did you open Orange via the terminal?
Yes.
So if you can go back to the terminal, I see that you missed some widgets.
Yeah.
So maybe there's a problem in there. Maybe you can have certain packaging stuff.
Sure.
You go back to the terminal where you started Orange, so we can close it.
Sorry, I have multiple. Yeah.
Yeah.
this-
Okay, don't worry. Okay. So if you can tap Control C,
Mhm.
then we'll close Orange. Okay. Now you can you are in the Darfix environment, right? You created an environment for Darfix?
No, I did not.
You should.
You didn't.
I just,
Yeah.
It's better to create an environment because then if you don't, you can have multiple problems between different versions of the dependencies needed. So
No.
if you want, we can try to create an environment now.
Yeah, the instructions were on the email.
Exactly.
If you don't know if you received the email because it's
Well, yeah, Peter sent me those. So
okay,
And why does he doesn't have access to Zoom?
because he's on behalf of someone else. So
Okay.
Yes,
it's access
yes.
were granted on name. That's why I
Okay.
needed the list of participants.
So let me.
Okay, so I will.
Day one, yeah. This no, it was before preparing for your Darfix tutorial, right? It was
Yeah,
that
probably.
email.
Yes,
Yeah.
probably that one.
No, okay. So
Uh,
virtual environment is this one or okay, but I don't have from. Is it? Can you see it?
No, now you cannot see it.
You can see my console.
Ah, the console, yes.
yes,
So this is it that what I'm supposed to do?
and then the path.
Uh,
Yeah, but the path to the new virtual.
But I should choose some path, yeah, to
Yeah,
my.
you have to create a folder
Okay.
first. If you want to do with it MacDear, you can create a folder wherever you want. And MacDear. Okay.
I don't know.
Good. And now you just do this.
Okay, sorry.
Now you have the, oh, that's good. Which version do you have of Python? Do you know that?
Sorry.
Do you know the version of Python? Do you have 3.9 C? Okay,
No.
just install.
Oh, I know. Sorry.
No worry, no worry.
Actually, this is very good for like I don't know how big everyone sees the console in their screens because we see it pretty little here, but it's a good installation from scratch in Linux tutorial. So
Yeah, and at the end, if we just run the workflow and anyone knows problem, then it would be finished in 5 minutes. So.
Okay, so now it. I
Now you
execute it.
created it, and now you can activate it. Also following the source
Okay.
to the path and activate. Being activated.
And yeah, The underscores are to be omitted, right? Or
Yeah.
okay, I do see some underscores in the.
This is perfect.
yeah,
Yeah.
And now you can do a pip install. I put it in the chat, okay? Because if you have a version.
It is in the chat. Yeah.
she's putting it now. There you go.
With the upgrade, you will have the last version of Darfix. Otherwise, it will take the one you have on cache. So.
Sorry, so I can't find the chat window.
Don't worry.
It's
Probably somewhere.
yeah.
It is somewhere.
It's pip install, score upgrade, and then Darfix. If you
Okay. Pip install. Yeah. And now
then score upgrade. Dash the upgrade. Yeah, upgrade now, and then Darfix.
no.
Okay.
Well, I met.
The ebooks are inside.
No.
I observed some DC errors even on Friday, but it ran. So okay.
Okay, it looks like it's installed. I don't know which version it says it's installed of Darfix 0.6.1.
0.0 download. You see here?
Yeah, but we see very little 0.6.
Can you make your command window a bit bigger?
Yeah, sorry. Okay, but
Oh, okay, no, it's fine.
I think control plus it made it bigger.
what do you think is you are worried about this?
Yeah, don't worry about that because, but the
Yeah.
problem is that it's installed, I don't know why, very old
An
version.
older version of Darfix, so you might find all the bugs that we have already solved.
Did you, if
Okay.
you go to the top of your screen, you should be able to find the chat at the top because where it appears the Zoom things.
Yeah, where you.
Okay. I probably, oh, here I see that. Okay. I probably has to.
Because if you find the chat, I
And-
will another
Yeah.
one to try.
Chat.
And
That's, okay, I see the chat. No.
you can try this command.
Okay.
Put them
No
both.
cache. No. Okay.
Okay, exactly. It still gets, so what we will try to find, but it works. The last version of Darfix, it's the one I put you in the chat now.
Yeah. Yeah.
But it works.
It's a strange stubborn.
It doesn't like it.
It's probably the issue with that errors now.
Yeah.
Yeah.
That one.
I didn't. I tried to go into detail, but I didn't figure out what's the
Yeah.
issue.
They works are on strike, so if you can try to open it, see if now you
Oh,
have a
no.
version you can work.
Sorry, no, maybe it's because of that. If you can, yeah, probably it's because of that. I put you another,
Okay.
and this I hope it works.
Okay.
I forgot the full, which will download all the dependencies. Let's see if that works.
The works are still on strike, but maybe this time it goes.
If we put, otherwise, if we put no cache, because I think,
Yeah, but I think after this one you should try because if it's start instant throw,
Yeah.
probably we can make it really complicated.
okay, now it's downloading all the dependency because without the full that I forgot to put at the beginning, without that full under brackets,
Mhm.
it doesn't download all the dependencies needed, and that's why
Okay.
it crashes. I don't know, when you install Darfix, did you put the full at the
I did.
Okay,
Yeah, but since it was out of an environment, they
Yeah.
might have collapsed with something.
Yeah.
but it's really weird because it seems like the same problem that they have in Windows.
Yeah, but I think the ebooks just having trouble with everything.
And maybe now, in the meanwhile, can you explain us this orange canvas? This is some kind of environment that just you are using for this data processing, or was it also developed in ESRF?
No, it's not developed in the ESRF, but we use it to show
Okay.
the workflows basically. So we create the widgets, but with orange to link them,
Mhm.
like you saw in the presentation.
Yeah.
So it's easier for us to create a graphical user interface.
No, it looks good. Yeah.
If you wanna not use the graphical user interface, then you can just take the widgets from Julia's page in Git and then use them in a Jupyter notebook or.
Yes. So it's not needed to use the graphical interface. You can use it also. Okay, let's see if it completes everything.
Oh, 3.31. Well, that was orange.
Okay, that sounds good. Now there's the Darfix and the ESRF packages.
I'd rather know. Orange seems to.
It still has the
Okay.
version of Darfix.
Oh, Oh,
You still have an old version of Darfix.
what was it that command that popped up window that the no that was something with changes?
If I want to restore the last crashed
Yes,
section.
no. Okay, that's
No.
weird now.
Could you go back to the okay, close, you could close the range. And maybe we will do a last.
Yeah.
I think this one should work because there was an error with evokes.
That was the problem with that application now, the
Yeah.
evoke store, I don't know.
Yeah, we can try. Okay, so we will try this first. Yeah, it's a package that it's used for the batch processing. It's a library that was recently developed here at the ESRF from colleagues of mine. And usually it works, but we have had several problems also with the video last week. So I talked to them and they are looking at that problem and we'll see, but it looks like it gives errors. At the beginning it just gave error in Windows, but with you it was the same. So what we will do is first uninstall the two packages. And then we will install the pluralist. Because I think the problems you have are due to that.
It says it is not installed. Yeah.
Okay, then if you can add the last.
Okay.
Still has some problems. Okay. It looks good. No, it looks good. That's very, very weird. I think, would you do an update of your packages?
This is the version of Python.
Because I think maybe it needs an update of the Linux packages. Because it doesn't found the packages because if he doesn't, yeah, I think maybe it's because of that.
So shall I try this again?
Yeah.
Yep.
No.
No, still, well, then we'll come to you with the solution once we get it. I think we should.
Okay. Good.
Exactly. For now,
I will use, so when using the old version, is there any problem with it? Or
No, but we don't know if you're gonna be able to save any data anywhere.
yes,
Probably the folder will be created automatically.
Yes, exactly.
But you might not have all of the widgets that we are gonna use.
Okay.
Okay.
Thank you.
So
Anyway.
I'm gonna go back to sharing screen and we will finish showing the example.
Oh, Bob is here. Bob, did you see the error he had in UX? Because maybe he can comment on that. Bob is one of the participants. Okay. Anyway, we will write him separately. I will share my screen now with here. Okay. So if we are back to the orange canvas and we have the data selection and the treated data, were you able to, I hope the others were able to find it. And you can then choose the folder you want. You don't have to choose it because you probably don't have this one. And then it should appear like this. And you can download the data set. And if you go here, you should also be able to add the metadata widget, which we already saw, so we don't have to go into that. And then the dimension definition.
We might skip a bit fast now till we get to the shift correction. But since you had plenty of time while we were trying to do the Linux install.
Exactly. I just removed the two modules that are needed and fit it. All is okay. It's possible that if you have older versions of Darfix, you don't have the range in here because this is quite new. Don't worry, the size also lets you fit, so it should work okay if your size is the same. Then after that, we go to the array selection. We select the needed body. So basically, just do it a bit bigger than it's by default. And apply. That okay. And back to the mesh removal. Compute the median with the dark data. Then the first one hot pixel removal. Then we go to the threshold removal.
In this case, we do it like this because we already know the data set. We have treated it upwards and downwards and back and forth, so we know what it needs. One thing that you can do is, as we showed you before, either use the palette and you change the color scale to know more or less what you're going to need, or you use the ZZoom widget, or simply when you get to your grain plot, you will find out that, oh no, I needed more of whatever, threshold, hot pixel, and so you'll come backwards and you'll do it again. And at some point, it just comes naturally.
So now I got that first hot pixel, then threshold removal, and then again the hot pixel. You could change also your kernel if you see that you have pretty big blobs, then you can change it to 5, and it will maybe remove them better. After the noise removal, we have the shift correction, which for now we will just find it along all the static images. You go to the terminal, you will see how it advances.
Yes, we did have some problem here.
So Wout is here. He is the creator of Evox. And maybe after we have finished with the demonstration, if we have time, we can go back to the error we had with Peter. I think he was Peter, yeah. And we see what problem has. Yeah, it's very weird the error. Well, because it loads a very old version of Darfix too, so it seems like a problem with the packages. It seems it doesn't find Evox, so I think it may be that maybe his repositories are outdated. So maybe it's not a problem with Evox itself, but with the repositories. See, we have time later.
They're hiding very well in the woods.
Yes, exactly. Yeah, because he has a very old version of Darfix that maybe it's from the beginning of last year or maybe last year.
I mean, I didn't even know that version of Darfix. So.
Yeah, so yeah, it should maybe it's beginning of last year. So maybe it's because of that. Okay, so back to the shift correction. We have set the shift. If you are using the same dataset, you should have found the same shift or similar. Maybe if you did a bit of the preprocessing different, it's a bit different, but
yeah.
After that, you just click the correct button and it applies the shift. Sometimes this is important if you use the on disk option. Sometimes you have the abort button in here. This button allows you to stop the processing you're doing right now if you think you've done something wrong or some of the parameters are wrong. Sometimes you can stop it.
Yeah. Mostly when you know that it's gonna take a long time but you already know that it's not gonna work, then you can stop it and reset. So the reset button is also very useful.
So now we have corrected the shift. If we move to the data set, we see that the lane is actually the same position of the.
And we also see that we will have to do more noise removal because at some point the hot pixels go up again.
Yeah, but it doesn't seem to have more than before. You see? Well, yeah, because of the Wavelet. We do the Wavelet now?
Yeah.
So it will take a bit of time maybe to open because And now it's computing all these different maps, center of mass, fluid maximum, etc. But we can already compute the orientation distribution. This is where, if you have a shortened version of the dataset, so if you have the dataset that we sent you last week, this will be different.
Yeah.
Because as you don't have as many images, the OV pitch value just go from 0.00 to 0.01.
Yeah, so you will only have one portion of the list.
Exactly. So if you go to the center of mass,
You will see two things. The first one is that you have amazingly a lot of noise. Well, this might be coming one from having shift correction. Normally after the shift correction, you can apply a second noise filter, as we mentioned before, with a very low threshold, because it's just to move the noise that has just drifted along the hot pixels that were remaining, have moved along the data set, and now they are everywhere. And also you can see that the side of that can have been generated by the shift correction, you have some very bright spots in the screen or very dark spots in the screen, and those might be remaining hot pixels.
exactly. So for now, we won't do again the noise removal, just because we don't need now to have perfect data, but just so you know that you can do it. If you will go to the Mosaicity, we see that we have still some noise.
Yes.
This for better to have a better map should be white. Yeah. But in principle, applying noise removal after the shift makes this better, right?
Yes.
So with this, you could compare this map to the orientation distribution map and say, okay, so the blue one is around here, etc. Like I explained basically in the presentation.
Yeah.
Then we have these other maps
that come out like this because you still have noise. And
exactly.
once you correct that, they will start being a bit more normal. So actually, these maps, the third and the fourth order moment, give you information about the tails of your curve, which is what you basically will remove with the threshold removal. So if there's still information there, then it will be everywhere.
Exactly. Okay. So then we can go to the another thing. When you are in the rainbow, you can export your maps. So it will export your map in an HDF file. So basically, if you want to try, just say
That will export all of them.
Exactly, all of them at the same HDF file.
Yeah.
Basically, the only thing that it's not, well, it is exported, but you cannot see it directly using the viewer in HDF5. To view this kind of maps, we usually use Silex. Silex allows you to view HDF5 very easy, just by doing Silex view.
In the environment that you have created?
Yes, in the environment that I have created, because you would have Silex installed. On there, you can open again this safe map. I can actually show you how to do it. If I open again the environment.
Yeah, you go to the environment.
And then I go to the Silex view. And then go to temp,
13 days.
14 days. My folder. It was the two one that had the
and wrinkle. I don't know if it's saved it in Widget.
Yeah.
Oh, question. Actually, yeah, that's the thing to Tobias. The Silex package is already downloaded when you download the Darfix. So if you open the environment, you can always open it from there. And then, yes, you can also install it independently, as Wood said.
So in the Silex view, you can see the different maps. In here, for the Y and for the pitch in this case, also the mosaicity map. The mosaicity map, you should click in here, because if you go under the mosaicity you have here, you will see different values for each one of the three of the RGB.
Excuse me.
Yes.
Just okay. I got it running, but I'm a little bit behind you. What were the dimensions to select? Diff RY
and OB pitch.
OBP.
You can just try to use the find that you change the metadata type to positioner first of all. You make sure it's in that way, and then you click the find dimensions button.
No. What was the first step you mentioned? Like,
Select the positioner in the metadata type. You should have metadata type and then
Yes.
Default. It would be by default as default, but you change it and you put it to positioner.
to positioners. Mhm.
Yes.
Positioner. Yeah.
Yes, and now it's like this. You click the find dimensions button.
Yeah. It selected the four dimensions actually. Even FFZ, and so I should remove the two. I should keep only the DFF RY and OB.
RY and OB pitch.
Exactly.
Yeah, I wrote it in the chat here.
Once you have DFY and pitch, you click the fit button, and it should tell you that everything works fine.
Okay, it is good.
It's okay. Then you click the OK button,
Yeah.
and you can load the other widgets that we commented.
Mhm.
You don't have the at your version. You don't have the transformation widget, which by the way we forgot to add at this time. But
I think we should clean the data again if we're going to try to do the blind source operation.
to have better output, you think? Okay. So for those,
We added.
while we wait for Peter to finish with the ROI, we will go back to our workflow.
No, show me the workflow, please.
Yes, I'm going there.
So
This is the workflow.
ROI now, okay.
And we will do here, after the shift correction, we will do
And
another.
second removal.
Exactly.
Okay.
Let Peter see the workflow. And for here at the second removal, we will remove hot pixels and threshold. If we want, maybe we can change the logarithm.
Yeah.
If we will have better view.
Mhm.
There, for example, see that the windows.
Yes.
Some pixels still. You can remove them, but since we did the English removal.
We remove threshold first, maybe to.
Yeah. Yeah, one or two normally it's sufficient, but
Let's move it to 2. And then we will remove again the hot pixel just in case.
So noise.
You can see now hot pixels.
how much?
Yeah.
There's still some, but
Yeah,
maybe
but-
this doesn't bother us so much.
If there are still some, we can just.
The more
compute them again.
information you have on the different orientations, which is how it was assigned in the simplicity map, the harder it is for the line source operation to compute everything.
How are you, Peter? Does it work okay on your side?
Yeah. I'm placing more or less the.
Okay.
Yeah. Anyway, the data of each item can be modified. The afterward.
parameters, you mean? Yeah.
So shift correction. Let me just do the shift correction.
Yeah, don't worry. We can wait for you. There's not a lot of widgets left, so we can wait for you 2 minutes. And then we can do it off together.
In the meantime, if anybody else has any question or has found any.
One question in the grain plot. Which image is the actual strain now? Is it the intensity image?
Okay, so in the grain plot, you have the center of mass, which, as explained before, gives you the center of mass of the peak positions for the two different motors. In this case, because you have both of them. When you have the mosaicity one, it gives you the combination of both with the weight of with a ponderation of the weight of both. So the HSV corresponds, it's ponderated with the diffra y, and the hue is comparatively over pitch in this case. Did I respond to your question?
Not 100%. Maybe I think how to formulate it again, and then I ask again.
Okay.
Maybe it's,
I saw that when I computed the rainfall, there is still noise. So I went back to the noise removal and I put a big another threshold just to hope that now it goes a bit better.
Yeah.
So that's the idea. You should just move through the pre-processing, see how the output is. If it looks fine, then you can leave it like this. Otherwise, you go back.
It is really important to spend some time on the processing. I mean, here you already see all the features of your brain, but the borders are fluffy and the hot pixels are many. So it can definitely be improved.
Now it starts to be better. As you can see, the white begins to appear, but it still appears some. So for now, we can leave it like this.
Yeah, we can leave it like this. After this, I mean, you already see the borders well defined. So after this, we can post-process. But yeah.
Exactly. If you want, the problem that if you apply a lot of threshold removal, there's a possibility that you lose information on the brain. So I don't want that. That's why you should be careful on when applying. Maybe it's better to apply several times for pixel removal than to put a very high threshold.
Yeah. One of the ways to see if you have overdone it is normally to go to the screeners and the details. If the details don't show you anything, is that you have completely filled. Yeah, so here we still have some, and also you have a very big contrast because of the noise. Yeah. So you can actually tweak it in the color scale.
In the color scale here.
The other way around. Like that you hit the parameters, and then if you lower the yellows, you will see something inside the but yeah, so we shouldn't keep removing much. You can still apply hot pixel quite a few times if you want. You can use the kernel pipe, but you shouldn't go overboard because else you will lose the features inside your brain.
Peter, how are you? Did you
It's
manage?
okay. Yeah. Good. Go ahead.
Perfect. So after rainbow, let's go to the rocking course. Okay, so as I told in the presentation, here you have your stack of images. Now you have all your images in here. So if you click on one of the pixels, as you see, you have all the peaks for every one of your motor values. That's why it's important in our case that we have two motors to filter by dimension. Yeah. And now when you change the value, you have different stack of images on the left. We can move through it and see where they are in the rocking curve. So that we can feed the data. We won't do that now because it takes some time, and we will try to show you another data set. But the idea is this one.
Yeah.
Once you feed the data, your export maps will appear here, and you will also have the option to export them, like we did with the report. Yes. Also, we can move here or we pitch, and we will have also your working course like this. You can center the angles here. The intensity threshold is also very useful for feeding the data to make it faster because, for example, in this case, at the pixels that are not in the brain, you have a lot of them that are zero actually. They are zero or maybe they are very, very low. They have very low intensity. With putting this intensity threshold in here, you say, okay, all the pixels that have less intensity from maximum to minimum, that this value here, you just don't fit them. This will make much more faster your fit. After that, we move through the Blanchard separation. So the Blanchard separation first, go to, you put Blanchard separation and you put two PCA. The PCA widget, it may take a minute or so to compute, but it will show you how are the components represented in our dataset. So it helps us see how many components does our dataset have. This compared to the mosaic city map will help you decide how many components you should choose in the right source separation. You can also have the detect number of components here. This does it for you automatically, but of course it can be wrong because it tries to use all components that represent, I think, maybe a 95% of your data set. So if you have a lot of components if you need a lot of components to represent that that part of your data set, then it will give you a lot of number of components, and this is not what you want. You will try to have always the less number of components as possible. So let's see if it has finished. Yeah, it has finished. So as the example we saw I don't know, this is not the same example we saw in the presentation, but it's very similar. That's why the course looks very similar too. And we would say, okay, now we choose three components, same as we did at the presentation. And we choose the Nika NMF method. For the Nika NMF, you will have in the terminal here, you will have first the data composition matrices. This appears while it's computing Nika. And then it will compute NMF, which doesn't have any input any output in the terminal, so you just have to wait for it, but it doesn't take so much. And here you have it. So these are three components. See, and here are the rocking curves. That's same as we did in the rocking curve widget. You can filter by dimension and see. Okay, so
here, after you select the right dimension, you have the choice of static motor, which is the same. But so you choose the one that doesn't move.
Exactly.
And then what's interesting here is when you have two motors, for example, a strain map or a density map, you can plot the rocking curves as a two-motor map, and you get a sort of reciprocal space map of the component that you're visualizing.
Exactly. So this is the reciprocal space map for this component, and if we change the component, the corresponding reciprocal space map changes too. After that, you can save the components by clicking at the button here. I think you don't have this option, Peter, at your version.
No.
But when you upgrade it, you will have it.
But he also doesn't make to save this particular thing now, so
Exactly.
whenever
So you can just save it. If you want to save it, all of you, because we will maybe use them later if we want to show the components widget.
I don't know
If we have time, we will show it, but you can save it. Otherwise, you can try it by yourself.
Yeah.
Just save it and then open the components widget and upload this file. So I think we have finished. Just tell you in this part here, once you have finished with your noise removal, and sorry, when you have finished with your shift correction, this you won't modify anymore because all your noise will be removed in this widget here. If you don't have a lot of memory RAM, or if you think you may be full, you can here put the flash widget, which is new, Peter. And this will be doing is it will remove all the information in here. So if we go here as the noise removal, these images are the same as the ones we have in this noise removal. But Peter, you don't have this because it's new. It's not in your version.
No. I finally succeeded. I read the upgrade and I succeeded in installing the.
Oh, yeah?
great.
Oh, good.
Yeah.
So you have the last version now. You have all the widgets?
Yes.
Perfect. Perfect. So now we will do a second workflow with a rocking data set that only has one moving motor, so it will be a bit faster, I think. You can save this one if you want to go to it later.
Later on.
I don't know how much time do you have in Learn, but if you are in your computer, you can also save it.
1 more hour.
Yeah. So I will save it like it's the straight one, and I will go to new. And
Yeah, if after the tutorial, during lunch or tomorrow or tonight while you're sleeping, a question about Darfix pops up, please don't hesitate in contacting us.
yes, exactly. And if you have any errors like Peter had, you can install it. That's why we are here. We can do a Zoom meeting and you can show us if you have any problems. Okay, so same as we did before, we go to the data selection to create a new workflow. But now we upload when going to we go again to the Darfix tutorial, folder, and we go to the logging folder. These is a much less.
It's a very, very small data set
Exactly.
that only has one motor moving and only has like 30 or 60 images.
Exactly. We don't have any dark data, so now here we don't enter anything, and we can go to the previous to your previous folder that you've created with your name on it. You can maybe create if you want treated too. I have it already, so I will use it. And this will create you another treated inside, but with your with the treated data of this particular workflow. After that, just click OK. It will be fast loaded, and we go through the metadata. Although it's pretty much the same as before, you can see it. You can go to the moving.
This is also
It's a different
scan. So
exactly, if I white go to default. This actually has we'll see it now. We see that it's an A scan with 81 steps.
yeah.
After this, you add the dimension definition widget. And final dimension.
And when you try to fit, it's going to give you an error.
Exactly. I just will put this. Okay. You try to fit. Oh, not enough dimension.
And this is a bit what Tobias was commenting on. After the step size is not correct. It's actually only 0.005, and it counted 51 for some reason. So when we do fit now, it should fit it fine. And there's actually the 81 steps that should correspond to a step schedule.
Exactly. So when you fit, these parameters will try to be fit and to be corrected if it can. That's why this 80 was corrected automatically. Once the fit is correctly done, you have your 81 size. We can continue. Here we don't apply any regional. No, we will apply it actually. We will apply it so I can show you the fitting done in the working course, because otherwise it may take a lot of time because these images are quite big.
Here you have another very different example of it. Okay, so the first one was a single grain in the middle of the space. This is a continuous film that has been looked at in reflection. So it's taken all the space you have. There's no such thing as living borders around it. What you're gonna want to do is to cut a small region of interest that is representative enough, or that you can find some feature of interest in, so it's as less heavy as possible. And so Julia chose region in the center of the image.
Actually, since you don't have a lot of images, it won't take a lot of memory and it won't be very long if you don't do the region of interest. But for the learning course, it will be. So now we don't have a lot of time. Normally, you wouldn't apply any region of interest. I would think if you want to use all the data.
And if you only have 80 images, you can.
Exactly. And if you change to logarithmic, you will see that you will see something, because otherwise, without removing the noise, you don't see anything.
It was a very sharp peak with very long tails.
Now I've applied a region of interest. And now we remove the noise as before. First of all, we'll subtract the median, in this case from the data, because we don't have any dark files.
And now once you have subtracted the median, you actually do something else.
This is not logarithmic, which is, but you already can see something. You can also remove some bits because there are some in here.
Yeah, there are some whole pixels, but not many.
And
then you're very careful with the threshold removal in this one, because you don't have a reference of what should be complete
exactly.
void.
I don't know if you should actually remove any.
I normally do something like 2 to 5, something like that.
Okay,
So 4 is good.
4 is good. Then we'll use 4. And
Now you don't have data.
you have data, but okay. Here we don't do any shift correction.
No, because first it cannot really find it, and second it's very small. If you try to do a shift correction in this one, if you do it automatically, actually it finds 13 that it's not real because of the stripes that are all in the same direction. The shift correction gets confused, so after you find the distance between stripes instead of
Exactly.
the real shift. Sometimes you have to work with what you have.
So after the noise, we go directly to the grain plot. Here it's only one dimension, so we don't have it. We don't have the mosaicity or the orientation distribution map.
But you still have skewness, choices, and so on and so on.
Exactly.
So you see that there's two very intense peaks where the dislocations are. Those were dislocations that went up to the surface of the material. And when you look into the skewness, you can see a bit of like the shape of the tails. So it should give you more information if you. Yeah. So there you see all the other lines that were around. They were a bit more embedded instead of being directly with them.
Here are the photos. As you can see, we can still see some hot pixels, so maybe we could apply 1 or 2 more times.
Yeah.
But it's okay. And then going to the rocking curves. Here we won't have now the filter by dimension because we only have one motor, and it works fine. And here it doesn't matter because I think all the pixels have rocking curves, so it doesn't matter the intensity threshold since we don't have a grain to that to be fitted. It's just all the image. So we just feed the data, and we look in here how
it processes.
For example, now it says okay, it's 5 minutes, so it's still a lot, even though we applied a region of interest. So we will leave it computing, maybe in 3 minutes and a half we have it. That's why it's important to have multiple cores. That way, when we allocated some memory, I asked Gabriel to give us 5 CPUs per person because if you have more CPUs, this process goes faster because it's in parallel. While this computes, I think we can go to the line source separation widget. And I won't compute now the PCA widget because it may be quite heavy, I think, although we don't have a lot of images, but I will directly do this and I will just try 5 components just to try them out because in this case, I don't know if the blind source finds.
I don't think the blind source finds many because there's a lot of different orientations there. But I would say there's like physically speaking, what would make sense is a component for the surface dislocations, another one for the other stripes that's horizontal, and then the film. So I would say something between 3 and 5 would make sense.
Okay, so we put 3.
And then to my surprise, it will be something completely different. And then I am the scientist that's like, why my components don't work as I expected?
Yeah, the components depends on the dataset plot if you find some or not, but it actually worked pretty good being so experimental, and I think that we implemented by ourselves.
Excuse me, may I have a question? When I do the grain plot, I have only one frame. I don't know why.
Yeah.
Is this with the rocking with this last example? Yeah, because you only have to move it. So
Okay,
if
so
you
it's correct.
find you the center of mass of different y, this is normal.
Do you have the same
Okay.
as I'm showing now?
Sorry?
Do you have the same as I'm showing now?
Yeah, I do.
Okay, yeah. It shows as many maps as dimensions you have. So in this case, with one
Okay,
dimension,
it's
we'll have-
only one. Yeah, good.
And you will not have access to a mosaicity-like math, like because you only have one.
Okay, so now while we leave, I don't know how many times do you have left in the working course, but maybe you have 2-3 minutes. So while this finishes computing, we can.
There, it's
Oh, okay, this is done. So the blind source separation has finished for us, and we can look at the 3 components it has found.
actually, instead of finding the components as I thought, like for the dislocations on the lines and so on, it seems to me that it found them in depth. So it separated 3 different data blocks that are at 3 different angles.
What did you use as threshold for the rocking curve?
We did not.
Yeah, 10. No.
You can use the one that is. You
Okay,
can use
okay, I see.
It's
I
not
see.
important. It's not important.
I mean, in this case, it's not important because you have data all around. If you have the blank space and the data, then you should input a threshold that you know it's gonna correspond to the parts that has.
And that's it. In this
intensity.
way, the pixels that with low intensity won't be used.
Yeah.
Okay, so I think for this we are finished. I will see. Okay, here we have maybe 40 seconds left. I go back here and I don't know if I can explain you a bit some of the others, maybe with the link components.
Yes, so we can try something fun and input the components from the first dataset twice.
We can do that, yes. So when you open the link components widget, you upload, now you go back a bit and you upload the, it's not in here, it's in the other, you will go to the, yeah, it's that. We crashed it. No, we didn't, but we are.
So yeah, one thing that is important is that you should be patient with Darfix. You should run something in parallel out of the environment and so on. So on, if you want to keep doing other tasks, it's okay because sometimes you have these waiting times for the fit, for the finding components, for the computing of the components.
It usually works, but maybe it just stops your computer or causes your computer for a moment.
These components and we link them today because it's have to do with each other.
Okay, so we will save also the second set of components we found with the rocking, which is this one as components 2 in this case. And then we go back to the link components and we enter first the first component we found with the strain and then the second components.
I mean, we technically could load twice the same data set and show you how well it works. And it will tell you this image is identical to the other image that's identical to this image. But in this case, we have 2 data sets that are from 2 different materials and have nothing to do with each other. So we're going to try to break the program and see how it works.
The normal thing would be that it simply doesn't find any feature matching, which is what happened exactly. So when it tries to fit it, it tries to find features between the 2 sets of components, and if it doesn't find for an image, it doesn't find any, then it just
blank.
Exactly, it just doesn't match it. And with this, look, it found something.
Yeah.
Although it's not good, but just so you know that sometimes it can get it wrong. You can also change here a different. I think the shift for now is not working, but you can also use the Euclidean distance.
Yeah.
And
Euclidean distance is very useful, for example, when you're trying to find a feature moving that has changed. So it's a feature that changes along the dataset, but it's more or less in the same position, for example.
okay, so to finalize, we go back to the rocking curve, which in this case it has finished, and we see the full maps it has created after fitting. So this is the big position, and we can also go to the residuals.
And you see the part that was not fitted so well.
Exactly. So as we can see here, for example, this pixel, it has like these peaks in here very blurred, and it fitted this one. So the difference between these peaks and the rocking curve and the right rocking curve is what we see in here for every one of your pixels. So as this is not, as our dataset doesn't have a very Gaussian function, it doesn't follow a very Gaussian function, then it's normal to have some residuals. It depends on the data set.
Yeah. This one is particularly like to show you how things sometimes don't work, and because it's very fast to treat. But
yeah, and
in
also
in the grain, you can find Gaussian curves.
Yeah,
around.
Yeah, the grain has actually got a few residuals.
Okay.
And you can also export your maps and enter, save both your maps. I think check that. And I think that will be it.
Yeah, we have 4 minutes left. If you have any questions.
Can you hear me?
Yes.
I have more general question. We are interested in the usage of the method. So can you do some recommendation regarding the number of grains, the size of the grains that can be really probed by this method?
5 microns and up. We can do a bit smaller, but it becomes really, really complicated.
5 microns a minimum grain size.
I would say, yeah. I mean, you can do a bit smaller than 5 microns. But 5 microns and up is good.
Okay.
After it always depends on how bright your grains are going to be, right? So it's if the material is not absorbing much and we have a good leak of intensity, maybe we can find something a bit smaller, but yeah. The resolution of the technique goes down to the 150 nanometers, but then you will have 1 pixel or 2 pixels, and that's not what you want to see.
And the number of grains?
So we recommend to take your grains one at a time, but in 1 week you can look at a couple of grains. And one thing sometimes correct is to, yeah.
But how do you deal with the overlap? I mean, there should not be too many grains to.
Yeah, but in a polycrystalline material, normally the orientations differ, right? They are not all oriented the same.
So there is not this this issue. I mean, in 3D XRD, we there are some limitations of
yeah. Yeah, sometimes it's interesting. So there's the double filter of you're gonna go to a certain position in your sample, you're gonna find a grain that diffracts in a particular direction, and most likely the grains around it diffract in different directions that are not very clear. Sometimes it's interesting if you have two that are close, sufficiently close, because then you can study the grain boundary between both. But yeah, normally we take it 1 grain at a time. Sometimes you can take a couple of grains if they are all close by, or if you want to see how they evolve in temperature, you can see all of a stack of grains that is going up in temperature. But if there's way too many, you won't see them one by one, and then you lose a bit in the well, maybe you need a slicing. You always have to use the commensurate, because if you use projection, you will see a sum of all of your grains. But in general, it works.
Okay, and the time necessary to probe 1 grain?
It depends on how much information you want from your grain. If you strain is probably the slowest thing, and right now, depending on the size of the grain, and if you want to see every micrometer, nanometer of your grain, or if you want some parts of it, but we normally do overnight scans, and we get the complete analysis, mosaicity, strain, rock, and layers of grain features. And
can we resolve, I guess, yes, the phase? If during the phase transition, the part of the grain has transformed into another phase?
Yeah. I have done a couple of times phase transitions, and we normally track them down. We also have a diffraction camera, so you can see the full circle, and you can identify them quite easily with that. But yeah, in general, it should be possible. It's a bit less straightforward than just observing the image and seeing, oh, I have a distortion in this spacing. But yeah, you can definitely extract it after.
Thank you.
No problem.
Any other questions? Answered or?
We left a copy of the presentation in 10 to 14 days. If you wanna take it with you, it's a PDF.
Exactly. This way you can take a look at it, also have the link to.
Yeah.
And the tutorial has been recorded, and you will get
Yeah.
it available somewhere.
Yeah,
Mhm.
it has been recorded. I don't know if you like it
Yes.
or you can ask, but it's been recorded, so I guess. Yeah.
And yeah, if you have any other questions about Darfix or about the technique, you can contact us either on the email account that we left you or to our personal email accounts.
Yeah.
That should be around there in the platform for the users meeting.
Yeah.
Will be around and available for the next 2 days for sure, and then, well, up and out, depending on when the big time comes. But yeah.
Yeah. Also, if you subscribe to the mailing list, I will also send different updates we will do.
So thank you very much for attending. It's been a pleasure to tell you all about Darfix.
Yeah. I hope it was fine for all of you. I hope everyone found it interesting and understood everything and worked with the data sets we provided, because I think some of you had some problems at the beginning, you had some problems with Guacamole, but in the end,
Yeah.
we could manage. So
Yeah, please, when you leave the Guacamole application, close the terminals and the processes, exit the SLO.
exactly.
So the people from the cluster will be happy with us.
Exactly. I think with Control D, you can first exit the Darfix environment, and again, Control D will exit the allocation.
Yeah.
Okay, so is anyone, let's see.
Thank you.
Thank you for being here, for attending, and we will see you around, I guess.
Enjoy the users meeting for this year.
Thank you. And bye.
Bye.
Bye.